Hello and welcome to this month's 60 Minutes presentation. My name is John Kowalski. I'm part of the marketing team here at BIC Instruments and I'd like to welcome you. Today we're talking about dispersion and taking a deep dive into it. We have our business line manager, Mr. Andreas Stummer. He will be presenting today. The presentation will last approximately 45 minutes and we're hoping for a little time for questions. If you do have any questions, please log them in the chat box located, I believe, in the bottom right-hand corner of your screen, and we'll get to them time permitting. If not, we'll collect those and Andy or someone on his team will reach out to you directly. Also, we are recording this, and immediately following the presentation, you'll receive an automated marketing email with the link to this, as well as links to archives of previous web seminars. So feel free to take a look at a future time, share it with colleagues, whatever you like. Also, we may experience some technical issues. Our speaker, Mr. Stummer, is down in Monterrey, Mexico, and we've had some stability issues while setting this up. We think we got it worked out, but just in case, thank you for your patience in advance. So with that, Andy, it's all yours, sir.
Thank you, John. Thank you, everybody, for joining us today. I think we have these connection problems now under control. As John said, I'm here in beautiful Monterrey, Mexico, at our partner, Exacolor. And today we're going to talk about dispersion. Actually, it's the pre-dispersion process. It's the first part of the entire dispersion process. The next part would be about milling. So join us for that one. And we're going to go right in. So just going to give you guys a quick introduction about the company. Then we're going to talk about the dispersion process. We're also going to discuss different types of lab equipment, some production equipment capabilities that we offer. We're going to dabble a little bit in the quality control aspect, just to show you what kind of capabilities we have. And then also we're going to cover our Wallingford lab that's in BIC USA, where we have a dispersion lab. To do some trials and show customers the capabilities of our equipment before you decide to make a purchase. So you can see here the VMA Getzmann product line. We offer everything from a laboratory scale dissolver all the way up, pilot to production. We started offering actually production equipment in North America about 5 years ago. Before that time, it was all lab equipment. And you can see the company, VMA Getzmann, they own the rights to, they own the Dispermat trademark name. The company was founded in Germany in 1972 by this beautiful couple. On the top right, Hermann and Elke Getzmann. Hermann is still visiting the company about 3 days a week just to make sure that they still follow his design philosophy. And we'll talk a little bit about that in some slides to come. But BIC has had the exclusive distribution rights here for the US and Canada since 1988. The business is still in family hands. It's run by the two sons, Christian and Martin Getzmann. They have over 100 employees and they're a global company. So they really have a presence all over Asia, North America, and of course Europe, as well as Africa. They're all present. They are known to make high-end dispersers, dissolvers,
Yep, Andy, we seem to have lost your audio there. Hold on, folks.
I'm back. I'm not sure what happened. That Dispermat is the very first Dispermat that was introduced in 1973. And believe it or not, we still have customers that are actually using equipment that is over 30 to 40 years old. The motors hardly ever have any issues. The only thing that customers replace sometimes are these control boxes because they do get worn, but the motors are direct drive, brushless step motors they will really last a lifetime. Super well built, hardly any vibration, and extremely quiet. If you have ever worked with a Dispermat before, you would recognize that. So here is just a quick slide showing you the company located in Germany, about 60 miles east of Cologne, in a town called Reichshof. The companies all over the world, more than 100 countries. And one of the things what VMA is known for is its flexibility. Probably about 40% of all the Dispermats that are being manufactured are custom solutions. And we also have a really nice facility in Germany to show this type of equipment, as well as at Big USA in Wallingford, where we also have a demo lab, what I talked a little bit about earlier. So while we're dispersing, obviously we want to break up these binding forces, and mainly it came out of the pigment world to really process pigments better, and we differentiate there between the organic, inorganic, functional, and special effect pigments. And the reason we're doing this, obviously, to improve the quality of our coatings. So we're going to have improved gloss, better transparency, color, textural strength, as well as cleanliness of shade, or some of these attributes that we want to improve by producing a better dispersion. So in the process, we improve, obviously, we're going to have improved wetting. We really don't want to destroy the pigments when we reduce the particle size. We just want to break up these van der Waals forces, these invisible forces that hold these pigment particles together. And the idea is then to reduce these particles down to a primary particle size. We want to improve our color strength, want to improve our gloss, improve appearance, get better pigment efficiency. Obviously, it's going to help us also to save money by having reduced raw material costs, have much better product consistency. Our formulation is going to be better. And also, we're going to have a much more consistent particle size distribution, which will also give us hopefully better upscale results when we go from the lab space up to manufacturing. So if we don't do it properly, obviously we're going to have shifting color. We're going to have poor product stability, flocculation of our pigments. That usually is additive related. Sagging, leveling, settling are some of the other issues that come up if we improperly disperse our mill base, then reduce gloss levels, as well as the separation of some of the problems that would come up if we don't do a good job. So it's really important to remember the stability. So pigments require strong color fastness so that they don't fade over time. So also our brightness will be improved. So good dispersion will give us the best color possible. There's a rule of thumb that the smaller our pigment particles are, that will improve the transparency, we'll get better color. And then also, which is really important, especially manufacturing, we're going to save money by using less pigment. That's one of the big wins if we have a good, properly dispersed pigment. And then viscosity is important. The lower the viscosity, usually is better for processing, and then what's going to lead us to improved particle size distribution as well as processing. But we don't want to be too low in our viscosity, so there is a good range, anywhere usually from 1,000 to 10,000 centipoise. 5,000 would be really a sweet spot. That would be optimum to put in good amount of energy that we need to really break up these van der Waals forces. If the viscosity is too low, it's very difficult to put in the energy. And if we are too viscous, then it's also too difficult sometimes to, with the blade to get good processing parameters. And also if we are milling, it's difficult to get the product through the media mill. So one thing is really important to remember, there's sometimes confusion out there. What we're really trying to do when we talk about particle size reduction, we're not trying to break up the particles or the pigment particles. That's not what we're doing when we're dispersing. We are not destroying the particle. We are really only breaking up these binding forces that keep these particles clumped together. And when we have a larger cluster of particles, we call them agglomerates, and a smaller cluster would be called the aggregates. And we're trying to break up these particles, these binding forces, and then allow us to really get them separated to bring them back down to the primary particle size. And really shear forces are responsible for that separation. And then at the end, we need the proper additives to keep these particles in a suspended state so they don't flocculate back together. Our sister company, Big Additives, has a lot of good solutions for keeping these particles in a suspended state. So this is a nice slide just showing you different types of pigments under the microscope. And when we dive into the dispersion process, you can see on the bottom that those larger building blocks or clusters of particles are called the agglomerates. And we use a Cowles blade to break up the binding forces of the agglomerates. That will then give us the smaller blocks called aggregates. If we're going from the aggregate level down to the primary particle size, a Cowles blade is no longer efficient enough because we can't put in enough energy. At that point, we need to really do the media milling. Either we use a horizontal mill, a basket mill, or some sort of a vertical bead mill, or a 3-roll mill that will allow us to get down to the primary particle size. So I really like this slide because it breaks it out nicely. We start always first in the pre-dispersion process. That's the focus of our talk today, is the use of a Cowles blade. That's where we are wetting the pigments. And we are breaking up these larger clusters, the binding forces of the agglomerates. And then post that, we actually start the milling process. And finally, we put in the right additives to keep them in a suspended state. So when we talk about dispersing, the question always comes up, at what point do we actually stop using a dissolver with the Cowles blade and start milling? Usually the threshold is between 10 to 30 microns. It depends on the material. But once we reach 10 microns, it's really difficult to go down further in particle size with just a dissolver blade, because we can't put in energy needed to really further bring down these particles sizes. So at that point, we need to do the milling. And that allows us then to really go down below 10 microns all the way down below 100 or 50 nanometers, really depending on our product, what we're trying to do, what type of coating. The end use applications vary. So there's a wide range of requirements, but for a pigment particle to really end up below 100 nanometers or in the low nano range, we really need to use some sort of media milling system. So in the pre-dispersion process, it's important to remember always the tip speed is the critical value that we need to look at. How fast is our blade spinning? And we should be between 18 to 25 meters per second when we use a dissolver. And we have different types of disper mats for that. We're going to cover those later as C, LC, CV, CN, and AE. And then when we talk about fine dispersing or milling, there are different systems that we have: vertical bead mills, basket mills, horizontal mills, that we will be talking about in the next presentation, part 2, which will cover the milling process. When we pre-disperse and we use a Cowles blade, please always remember the right blade to container diameter. should be about 1/3 of the container diameter. So you can go a little wider or smaller depending on the viscosity of material, but this is kind of the threshold. And we have a really nice table also on our website where you can actually look at that table and look at the vessel that you would be using, and then it will show you the type of blade diameter that you in millimeters that you should be using for the different vessel sizes. So that is actually really good because you can see, for example, we use a 50 or sorry, a 200 milliliter vessel. You can see you have a range going from 80 all the way down to 40, depending on the viscosity of the material. So there are these different blade sizes that would work with that. Probably a 60 is what I would start with, and then work my way up or down to see how is the flow of the material. What we're always looking for, if we have an optimized dissolver batch, we want to have a really good donut effect. And that is actually the visual cue that you see when you look inside of the container. How is the product behaving? And in order to get that donut effect, we need to have the right tip speed. And when we pre-disperse, again, it's really important to remember we need to be between 18 to 25 meters per second. You can write down that formula. So the tape speed is calculated by pi times the RPMs times the diameter of your milling disc. And then if you want meters per second, you divide that by 60, and that will give you meters per second. And our instruments actually will show you that on the display with the C technology, so you don't have to do the calculation yourself. It'll be automatically displayed on the screen. And that donut effect I mentioned earlier, it really is called that because when you look inside of the container, if you're optimizing all the parameters, you should see an actual donut being formed. And that's a good picture right here. That's what that looks like. What's happening there is the particles are being dispersed, or these binding forces are getting broken up at the edge of the blade. On that slide, I think the missing is the bottom part of the blade because we also have some dispersing effect on there as well. So it's not only on top, it's also on the bottom where we are breaking up these binding forces, but it's really at the edge of our blade where these teeth are located, where that breakup of the binding forces takes place. And that will give us a really nice donut effect if we optimize our dissolver batch. So in this case, we operate here at 21 meters per second. And we're putting in about 850 watts of energy. So we can see the tape speed is good, and the amount of energy we're putting in looks good. And therefore, we have a really nice looking donut. Now, in this case, we have the same tape speed, but the energy we're putting in is 320 watts. Means the viscosity probably is really low of our material. I have a difficult time putting any form of energy in there. So therefore, there is no donut forming. Actually, the donut would automatically collapse as soon as it's being formed because the viscosity is so low. So to balance this, I have some options. Either I modify my formulation to increase the viscosity, or I can also play around with the diameter of my blade, maybe use a larger diameter disc to actually put in more energy, and that also allows us then to properly disperse this material. And then we have a case where we're putting more energy, but we are not seeing a donut. So in this case, it's the opposite. The viscosity of our material is really high, and therefore we're not seeing really a donut. So that's, again, I can play around with the disc or disc diameter, or I can also modify my formulation to bring down the viscosity that I can optimize my dissolver batch, and that will give me then again that visible donut. That is always the best cue to know what's actually going on during the dispersion process. So in order for us to optimize our dispersion result, it's important to remember always how long am I dispersing. So usually about 15 to 30 minutes pre-dispersion is a good number, depending obviously on the material that we're trying to disperse. We want to see the donut effect ideally. Again, your best viscosity range, I think, is between 1,000 to 10,000 centipoise. That's a really good range that will help you get to that donut effect. The tip speed, I mentioned it again because it's really important. You should write that down. You should be between 18 to 25 meters per second of tip speed. That is the sweet spot, the best range that will actually really break up these van der Waals forces. Anything slower is not going to yield the results, where you're going to just pre-disperse for a much longer time, and it's possible that you may never even get there. And then also, if we could go too high, we're just going to have material get thrown around our container if the speed is too fast, and that's not ideal either. So we find that 18 to 25 is a really good number. Again, the right geometry of our blade. There's a lot of different blade designs and types out there. You'll find them online, so that's important. And also the size. Again, each container volume, you have a nice range of different blade sizes that you would be able to use, depending on the viscosity of your material. For volume, it's good to be about 50% fill rate, 50 to 70%. I wouldn't recommend to go much higher, because then if you put in the energy, you're probably going to spill the material. It's going to come up. And if you plan on milling later on, for example, with the basket mill, and you have too much product in there, the basket itself has a lot of volume, that will just push up the material, and then you're going to have definitely a problem spilling. If we have less than 50%, the problem there is that then you may have difficulty properly oscillating. So if you need to move the blade up and down during the dispersion process, it's going to get more difficult, because you have some distance on the bottom. You don't want the blade hit the bottom of the container, so you're not going to have a really nice range if you're much lower than 50% of the fill rate. So try to keep it there, 50 to 70%. Optimize your pigment and filler concentration. Dispersing is an energy-intensive process. When we put in the power, the energy, we're running at high tip speed, we are automatically putting in energy. And that's what helps us break up these binding forces. But that also means we're going to have an increase in temperature. So when we are pre-dispersing, this usually isn't such a big problem. But when we're starting to mill, especially with the basket mill, we're going to put a lot more energy, and we definitely need to cool our basket. So therefore, it's important that you have the right type vessels. And if you are pre-dispersing material that is very viscous, I highly recommend that you also use some sort of cooling, because you're going to put in a lot of energy. And again, when you're milling, you're going to need it anyways. So you may as well just get it up front. These are jacketed vessels that allow you to hook up a chiller or tap water, and that will, circulate through the vessel and then keep the temperature as low as possible. Especially with solvents, if we increase the temperature, you're going to have flash off, more rapid flash off. So their temperature control is really critical. And then again, the right type of additives are really important during the dispersion process to help us improve our wetting and dispersing effect, and that these particles don't flocculate back together once you're completed with the process. So if and everything worked out well with our pre-dispersion process, would then move over to a bead mill. So here, just the comparisons, what the shortcomings are of a dissolver and why we can't really compare a dissolver to media milling and why we need media milling if we want to go down below our 10 micron particle size. Because the dissolver with the blade, unfortunately, only allows us to put in limited energy and limited shear force. And it's really, because of those limitations, only used to deagglomerate these larger particle clusters. And it is not meant to break down the aggregates to primary particle size. It's really almost impossible to do with some sort of media. And it is a critical step for any dispersion process that you properly pre-disperse. If you don't pre-disperse and you go straight to a media mill, let's say you start out with 100 microns or 80 microns, and you go to a horizontal bead mill, for example. You have a screen, depending on the manufacturer, or you have a dynamic gap, and there is a size that basically allows for the beads to stay back in the milling chamber and everything circulate back through the milling chamber until you're reducing your particle size to the appropriate size. If you have particles that are so big that you're putting straight into your media mill, they may clog your screen right up front and you won't be able to circulate any product through. So it's really important to always properly pre-disperse before you start the milling process. And you're also not properly wetting at that point, you need to do that beforehand. So it's a critical step, and I think it's a necessary step for any dispersion project if you want to have really, really good results. And if we only stick with the dissolver and we don't do media milling, we're going to have limited performance of our material. So our color strength is limited, gloss is going to be affected, haze. There's an array of other issues that will come up if we do not move over to a bead mill. In the bead mill, the advantages are I can put in a lot more energy because I'm using actually zirconium media, yttrium treated or serum stabilized is what we would recommend. No glass because of the kinetic energy, and also glass will break up much easier. So we want to use good quality beads. That allows us to put in a lot of energy, which will help us to further deagglomerate and get the aggregates down to primary particle size. And that final end result will give us the best possible product that we can achieve with the right milling system. And that will be covered in more detail in the second part of that presentation when we do the media milling deep dive. But here is an example of a laboratory dissolver. This is actually our flagship machine, or Dispermat AE. Has a number of safety features. Very important that H1, H2 setting. It's the working threshold in the container. These are settings. You have an upper and a lower threshold that allows you to safely operate the Dispermat at high speed in between those two ranges. And that also ensures that if you push or the operator pushes the up button, that the machine, the blade will stop at that H1 height setting. Also, if you go down too low, it will stop at H2 to ensure that the blade doesn't hit the bottom of your container. So that's really important. The second safety feature is our container clamping system. So you can see that wheel on the right side that's used to loosen and tighten the container clamp and to ensure that the container is always perfectly centered and locked in place. So you can't push it out. It's important that it's perfectly centered. You don't want the blade at high speed hitting the container wall. Metal on metal, especially if you're running solvents, is not a good idea at 20,000 RPM. So very important. And then we also have a shaft protection pipe that goes over the shaft that's outside, that's exposed outside of the container to ensure that there are no moving or rotating parts that somebody could get hurt. We offer explosion-proof models. On this particular model, the AE, we also have software that allows us to port the data over to a computer and look at the entire dispersion process in real time on a screen. You can also store data. You can store batches by name or product ID number to be recalled at a later date. So you always have really good reproducibility and repeatability with this type of equipment. This machine, the AE, is also designed for optimizing your upscaling process, which is also very important because a lot of the important variables, such as energy input, torque reading, temperature, all these things, tip speed, will have a direct correlation to our large scale production units. So it's very important to have the right technology if you're planning on moving from a lab scale to a production machine. So the modularity that I talked about earlier in the introduction, that's the reason Hermann Getzmann still comes into the company, is because the dispermats are designed to operate not only as a disperser, but that they're also fully functioning rotor stator machines, a bead mill, or a basket mill, or a vacuum system. All these different attachments are available, and you can turn a dispermat into a different piece of equipment in less than 1 minute. You move them from a disperser over to a media mill or a rotor stator or a vacuum system. That is the great aspect of a dispermat, is that fantastic flexibility. You can see in the middle you have a dispermat, and then the rotor stator on your top left. We have a vacuum system on the top right. We have a basket mill system on the bottom right. A wall scraping system is available. And we also have a vertical bead mill. All these are separate attachments that can be purchased at a later date, and they would all fit onto the same dispermat. So that means that you are buying one machine to do all your pre-dispersing as well as your milling needs. And you don't have to buy two machines. So you service one machine, you only need the space for one machine. So there is a lot of advantages that come into play with that kind of design philosophy. And not only are we able to achieve this on the lab scale, we can do that with our pilot units, as well as with our large scale manufacturing machine. They have the same freedom in design to move from a disperser over to a basket mill, for example, on our production dispersers. So we also have a budget model, which is called the LC line, which is a really nice small lab unit. Again, the same motor technology. These are brushless step motors, ultra quiet. You can hardly hear them, hardly any vibration. Just a standard small lab unit, giving you the speed as well as a timer on the display of our control box. We have also the next model up is the CV line. We have a new CV model going to be introduced in August this year. It's a really big redesign for us. That new machine will have that beautiful control panel that you see on the AE model that I showed you earlier, but you will also have the capability of adding a scale that will be basically displayed. All the scales will be displayed on the screen, and it's also designed so that you can store your data and then port it over to a computer. Beautiful machine. Also, same modularity as well as motor design that we talked about earlier. The CN line is our middle of the road line, really nice for its size. We can go from lab all the way up to a large pilot, up to 150 liters. Has also the same safety features that I explained earlier on this model, as well as the smaller models. The safety features are always present. On this machine, we can show the speed, the percentage of torque, temperature, as well as a timer function. And you also can set that H1 and H2 setting, what I talked about earlier, electronically on the display. So you don't have to do it mechanically. It's 2 buttons on here where you just lower the blade to the desired height, bottom height, push H2, then raise it up to the top, and then press H1, and that will lock these 2 threshold settings in, and you'll be able to then run the Dispermat safely. This is an example of a pilot-size CN model. Same control capability, just larger. This is the AE, the premium line, what I showed you earlier. That has that C control package with that beautiful C control panel. It basically also is very scalable. We have small lab models all the way to pilot as well as production. You can do what's called a net power calibration feature. So when you turn on the machine, you can set all the values to 0, because the Dispermat, if it runs even without a product, it would use energy just by moving the blade. Basically, you would set that all to a 0 value, that you know that the amount of energy you're putting in or the torque value would be only related to your material and not to the machine input. Excuse me. We can also program cutout values. That means if, let's say, we have a temperature limit, we don't want to go above, let's say, 80 C, we can program it so that the machine would shut off at 80 C or run at a different speed or different energy input. It would also allow you to basically program 2 separate warning stages. That means if, let's say, you reach 70 C, it would warn you at 75 C, and then at 80 C, it would react to how.
Yeah, we must have some technical difficulties here. Let's see if we can get him back with his audio. Oh, we're doing so well too. Okay, he's working on his end to try and get this reconnection. Also, keep in mind, if you have questions, please log them in the chat box located at the bottom right-hand corner of your screen, and we'll get to them in order. Hey, you're back.
I'm not sure what happened. I apologize. Seems to be a computer glitch. I saw I was online, so.
Yeah, strange. We can hear you now.
Okay. How much did you miss, John? That's
about 10 seconds. Why don't you just do a quick run through of this slide and then keep moving on?
Okay. This particular model is the premium model, the AE, very scalable. We can go from labs to production scale. We have the capability to do the net power calibration feature, basically allowing us to set all the power values and energy values to 0. And then when you're running your product, there will be no influence of the machine itself, because it consumes. Obviously, it needs energy to rotate the blade even without product. It has to apply torque to move the shaft. And by doing a net power calibration, we are factoring out those variables that it's really only strictly related to your product. The cutoff values can be programmed, meaning if you have a temperature threshold, you can set that up so that the machine will cut off at a certain temperature and give you warnings before that happens. We can run this machine what's called constant power, constant speed. Basically, if I'm running this at constant speed, let's say I'm running it with 2000 RPM, then the machine will automatically adjust the energy it needs to maintain the 2000 RPM, depending on the viscosity change of our material. but I can also run this machine with what's called constant power. So I can run it, let's say, with 1000 watts of energy. And then as my viscosity changes, my speed would vary. As my viscosity is increasing, my speed would decrease because I'm maintaining the 1000 watts of energy. If my viscosity decreases, my speed would increase because I'm maintaining the 1000 watts of energy. And that's also a really nice way of upscaling, because it allows me also to calculate how much money does it cost me to run this process in a manufacturing environment, because I know exactly how much energy will I be needing to process this material. So we can also store all the data. We can have, the batches stored by name or batch number. We can port the data over to a computer. We'll have a graphical interface where we can see each of these critical values in a trend line. And then we also have explosion-proof models available in the AE line. This is the palletized AE model, about 31 gallons of mill base, 150 liters. Same features as the smaller one, but just larger stand, larger motor, larger vessel. And then here is a production scale. We can go up to 2000 liters. Same technology, same motor technology here. We have the ability to also take advantage of that modularity, that quick change system. So we can rapidly change this dissolver and turn it over to a basket mill. So we can buy one machine to do both pre-dispersing and milling. We have the ability to add vacuum. So some customers prefer to disperse or mill without any air. The milling efficiency is improved. You don't need any defoamer. So there is a lot of advantages that come into dispersing or milling under vacuum. So we can offer that upgrade as well. And for really thick materials, we also offer the optional wall scraper system to ensure that all the material gets properly dispersed and the containers are clean of our product. Also, explosion-proof models are available as well. Here's an example of a vacuum production disperser in operation. Better wetting, higher energy input, no more foaming, allows us to quickly transfer product from one container to another. We have improved homogenization, cost savings. There is different types of vacuum pumps that are available that help us remove the air. And then some customers, especially in the renewable energies market, now have requirements to run this all with inert gas. So we have the option of adding a nitrogen purging valve. Some people like to flush it with argon gas. So these are options that are also available not only on our lab models, but also on our production scale models. Few slides about the quality control, or what do we see on our display. So the C control panel, you can see that on the left, allows you to not only obviously see and adjust the speed, but you can also do that same thing with the energy or watts that we are putting in. We can see the torque reading. That's a calculated value. If somebody needs an exact torque value, we actually have a torque measurement sensor that we offer as a separate package called the TMS systems, which has a resolution of 0.1 Newton meters, which can be really helpful because it's actually an indirect measurement of your viscosity during the dispersion process. And a lot of customers really benefit from that, to see what is happening to my dispersion during the dispersing and milling process. We can see the tape speed is displayed on the top right. We have a temperature readout as well as a timer function. The tape speed obviously is a function of our RPM as well as the diameter of our blade. So when I'm setting up at the trial, I will actually adjust or put in the proper diameter dispersing blade in the submenu, and then it would automatically and accurately calculate my tip speed. This is available for production as well as for our lab models. We also have, just for production alone, a more sturdy, more rigid control panel, which just gives us limited capabilities in terms of what we see on the screen, just the RPM, what the energy in terms of amps, and then a temperature readout. We also offer PLC controller here that allows you to program everything yourself, and that's sometimes helpful if customers want to integrate different systems. For example, we have customers that like to add a scale, and then basically all that would be part of the same units. You can weigh your raw materials in production, and that would then show up right here on the screen. Everything could be tied into different quality control packages. The bad news is that right now Siemens has a lead time of about 1 year on that custom PLC controller, which is really long, unfortunately, out of our control. We talked about that earlier, these cutoff values, so you can program that machine depending on what your temperature threshold would be. You can have cutoff values for your speed if you're running with constant power, or you can have cutoff values for your power if you're running at constant speed. So that's just some ways how you can design your experiments or your dispersion trial. Net power calibration, we already covered that, setting all the values to an actual 0 point without the influence of the Dispermat itself. So no energy that's displayed is actually used for the machine itself. It's strictly just for your material. This is actually the old version of our WinDisp. On a desktop computer, we're going to have a whole new software coming out hopefully next year. It's going to be a new WinDisp version, completely new interface. But here you can control the Dispermat. You'll be able to see all the dispersion parameters, your speed, temperature, time, torque, on that graphical interface. So you have a trend line for each of these values. And let's say your torque or your energy is spiking, then you would see, okay, I'm making progress in my dispersion process, or something good is happening. And I can see that in a trend line very easily. We have a really beautiful applications lab in Germany at VMA. So if you want to visit us, we can do trials over there. We have all the beautiful lab capabilities, but we also have a lab in Wallingford with a lot of equipment. This was one of the first pictures. We have more. I'll show you that in another slide, but we got small dissolvers, large ones. We got basket mills. We got rotostator. We got vacuum systems. We also have a horizontal media mill, which is the new SL mill that you see right here, as well as the new AE model we offer, and that you can come and visit us and run your product on these beautiful machines to see the performance and see how well they work for your dispersion process. So it's a Class A facility. We gladly have customers come in to show you the different milling techniques, what works for your process the best. We're able to also help you with scale up if you're interested in our large equipment. The good news is that we have this lab within the big additives facility that allows us to bring in special chemists for different end-use markets. So if you, for example, from the ink market or renewable energy or coatings, we have specialists that help us recommend or improve formulations, or recommend a special additive that then we can try out and show you the results to help you not only make good choices with respect to the right equipment, but also helping you optimizing your formula and give you a better technical package This is something that is a huge advantage, where some of the other companies, they're only experts on the hardware. We are a complete solution provider. And then if you want to just come in and look at the equipment without doing any testing, let us know. We'll gladly host you. And we can also use that location as a training or seminar location to educate your people more about the dispersing and milling process and all the other capabilities that we offer. So with that, this concludes the presentation today. Again, I apologize for some of the glitches we had with the connection, but thank you, everybody, and I open up for questioning.
Yeah, great, Andy. Thank you. Good stuff. And yeah, only just a couple technical glitches. Not too bad at all. Thank you for sharing your expertise with us. Got one question in here. Ethan writes, I need to break down solid, whoops, where'd it go? I need to break down solid pigment agglomerates and keep them dry to then dry mix them into a polymer matrix. Is there any product that you have that can get approximately 1 micron without using a liquid solution?
Yeah, so basically, our equipment is wet milling, wet grinding systems. However, we have customers in that type of situation. I would probably look at some sort of a closed environment where we can purge nitrogen, and that basically will mimic that of a liquid state. So we are able to dry process the material with an inert gas. So that could be an option. But we would be better off sitting down and really looking at what is the material. Is there a compatibility problem? Are there other options? I would tie in some of my engineering team to make sure that we have the proper solution. But if we want to go down to 1 micron again, we probably need to do also the milling, and we can also mill with the hydrogen blanket. So that's also a possibility as well. So that's often actually in the renewable energy market where that's coming from. They either use argon gas or nitrogen if they want to exclude any type of moisture. Hope that answered that question.
Great. Thank you, Andy. Ethan, let us know if that's, let's see. Yes, thank you. Great. Another question here from Paul. How do you keep acrylic emulsions from separating when grinding pigments?
I'm not too familiar with that problem. Can you be more specific? What he means by separating?
Paul, I've just unlocked your microphone. If you'd like to unmute yourself and chime in and elaborate on your challenge, you can. There should be a round circle with a microphone in it, red circle in your upper right-hand corner. If you just click that, that should unmute you. Oh, he doesn't have a mic. Sorry. Well, we'll get back with you. How about that?
We'll get back to him. I'd like to learn more about that.
Sounds good. Okay. Yep. He'll be in touch. We'll be in touch too. So other challenges that anybody has, we have about 5 minutes left. You can just log them in the chat box. Like I said, you'll immediately following this, you'll get a automated message with the link to this recording. Feel free to share it with colleagues, listen to it later. If you think of a question after the fact, don't hesitate to hit reply to any of those marketing messages. It'll come to my team and we'll route those to the technical expert like Andy. I think that might be it, Andy. Any final dispersion words from you?
No, I hope that this was, well, definitely join us for the second part of the presentation, which will be a deep dive in the milling process. This is the easy part, the pre-dispersion process, but when it gets really complicated, is when we do media milling, what type of milling system are we choosing? What are the advantages of a basket mill over a horizontal bead mill? What's different to a 3-roll mill? Why are some people, a lot of people are now moving over to basket milling? What are some of the advantages of basket milling in manufacturing? So there is a lot of good there are a lot of good slides that explains the intricacies of the different milling systems in more detail. And hopefully, the listeners will have a better understanding of how to implement that into their lab space or manufacturing process. Be surprised how many people are totally new to the theory of basket milling. And when they learn more and they come and visit us and actually do run trials on our equipment, they are so happy that they're now able to move away from horizontal media mills because of the ease of use, cost of maintaining the equipment, speed of cleaning. So there is a lot of advantages. Yet it's not always the perfect solution. In some instances, we definitely need to use the horizontal media mills, especially when we have very, very small particle size and particle size distribution. So that's a different topic for the next presentation. We'll do.
And that is scheduled for June 13. I put a link in the chat if you're interested in registering to join us. And there are no silly questions here, but got a question. What's the difference between dispersion and milling?
Yes, so both are dispersion. So dispersing is basically the larger terminology. You're dispersing also when you're milling, but we actually have, so they're the same thing, but dispersing is 2 parts. We have the pre-dispersion process, which we talked about today, which is using a blade efficiently and effectively, but dialing in the correct parameters. And then when we reach the right particle size with the minimum of 10 microns, of between 10 and 30 microns, then we start the milling process. That allows us to take these aggregates that we're left with and turn them down to primary particle size. That's the most important step to go from the aggregates down to primary particle size is the milling. So both are part of the dispersion process.
Good. Great. Thank you.
And again, sorry, go ahead.
No, go for it.
No, that new CV3, we're going to send something out because that has that new lab model that we're coming out with. You have to see to believe it. It's a beautiful machine. Completely, it's a game changer. Also with the scale, that's a part of it. You need to see it. We're going to have something sent out to customers, a flyer or something, John, on that.
Yeah. We'll put all that stuff together once the product's available. One last question. Constant power. How is that achieved, or is that a setting in the system?
Yes, constant power is just a setting with our C technology that you're basically locking in the amount of energy you're putting into the mill base. So 1,000 watts, for example, and then the machine would automatically adjust the speed depending on the change of our viscosity to always maintain the 1,000 watts of energy. So that's the constant power.
Gotcha. Nice. Well, thank you again, Andy. Thank you for everyone who attended. Thanks for your patience with a couple technical glitches here. You'll get the recording link momentarily. And we hope to see you on the next deep dive into media milling, June 13th, same time as this, 2 p.m. Eastern. Link is in the chat. You'll also receive an email a week or so prior with that information as well. So thanks everyone for attending. We look forward to seeing you on future BitGardener web seminars. Thanks and have a great rest of your day. Thank you, Andy.
Yep. Thanks, everyone. Enjoy your day. Appreciate it.